Good morning. So we're going to look on page 32 of our notes. So page 32 is what you need to turn to. And it's a new type of simultaneous equation. So far we've done our normal simultaneous equations in 2 variables, our tripletaneous equations in 3 variables. And the next type is solving, it says solving quadratic and linear. It's not quite limited to that. As you can see, this is not a quadratic equation. We have a y squared in it. So I prefer to call them line and curve. Now we remember that when we're solving simultaneous equations, what we're doing is we're finding the point of intersection. So whenever we're solving simultaneous equations, and these are a type of simultaneous equation because we have 2 equations that we're solving at once. So any type of simultaneous equations means that we're looking for points of intersection. Those 2 things are synonymous. If you're asked for points of intersection, you must do simultaneous equations. If you do simultaneous equations, what you're doing is you're finding points of intersection. So if we imagine what's happening when we're finding the point of intersection of a line and a curve. Now it said quadratic, so imagine a U-shaped quadratic equation drawn like this on my x and y axis, and then I have a line going somewhere through my space like this. So I have a line and a curve. What happens? Well, the line and the curve will intersect at 2 points, usually. Okay, so lines and curves usually intersect at 2 points. Now, of course, we could have a line that only intersects at 1 point, tangent to the curve, or we could have a line that doesn't go through it at all. And we'll talk a little bit more about that later. But usually we get 2 solutions to these types of questions. 2 values for x and 2 values for y, which give us our points of intersection. Okay, we can't solve these the usual way. So the mistake that most people make, the approach that most people make with these is they go, okay, I'll try and cancel x and I'll change my signs. But the problem is, if I try to do that, I'm going to write this in pencil because it's wrong. If I had, say, x plus y equal to 5, and then I did minus x squared minus y squared equals minus 12, this is nonsense. They don't cancel because they're not like terms. They're not like terms, so therefore they don't cancel. In fact, if we were to write something down, what we'd write down is x minus x squared plus y minus y squared equals 5 minus 12. Okay, so there's nothing we can do here. We can't do that. So there's only one way of solving these. And you'll know, they won't tell you that they're a line and a curve, but you'll know that one of them is a curve because we have a power of 2. So powers on x or y means it's not a line, it means it's curved. So the powers on x and y means that it's a curve. The other one, the top one, is a line because I just have x and y with no powers on them. So this is a curve. In fact, it's a circle, but you don't need to know about that yet. And this is a line. So let's go through the process for how we solve these. The first step, so we can only solve these by substitution. We can only solve these by substitution. Okay, so the first step that we're going to do is we're going to use the line to write x in terms of y, to isolate one variable. So usually it's x in terms of y, so instead of x I'm going to have something, something, something. let's look at what we have here. And instead of x plus y equals 5, we manipulate our formula and we say that it's x is equal to 5 minus y. As soon as you've done that, you want to put that in a box and call it star and label it with whatever symbol you want. You want to make it really clear because you're going to need this later. Then what you do is you replace, you substitute for x in the curve equation. Okay, so what does that look like? Well, my curve equation was x squared plus y squared equals 12. But I'm going to replace x with 5 minus y. So everywhere I see x in my curve, I'm going to replace it with 5 minus y. So I've got 5 minus y squared plus y squared equals 12. And then we multiply out the brackets and we will get, so you multiply out and simplify, we will get a quadratic in y. So let's see what that looks like. So I'm going to multiply out these brackets. I'll square the first, 25, square the last, plus y squared, double the product, minus 10y, plus y squared. I'm going to bring my 12 over at the same time, minus 12 equal to 0. And then I tidy that up. Put that up here. Tidy that up and I'll get y squared plus y squared, 2y squared, minus 10y. 25 take 12 is plus 13 equal to 0. Okay, then you solve that quadratic and you'll get two values for y. Solve the quadratic and we get two values for y. I'm going to use my minus b formula. I'm fairly sure this will solve by factorizing as well. So I've got y is equal to minus b plus or minus the square root of b squared, I'm just squaring it 100, minus 4 by 2 by 13, 4ac, all over 2a. So this in my calculator, just do it in a different colour, is going to be 4 by 13, 52. Does that not work out evenly? We've got the square root of 10 squared minus 4 by 2 by 13. I'm just double checking that. The square root of 10 squared minus, oh, we have no real solutions. I think there must have been an error in this question. So let me just double check my substitution here. 5 minus y plus y squared equals 12. 25 plus y squared minus y by 5 is minus 10. Plus y squared minus 12. Okay, so the discriminant in this case, I'll have to do the next one. The discriminant is less than 0, so that means no real solutions. which means the line doesn't intersect the curve that I'm given here. So I think there must have been a problem. There must have been a mistake, a typo here when the notes were redone last year. I'm going to go on to the second one. I was going to just do one example, but because this one didn't work out, I'm going to go through the steps again just to show you how this should work out. I'll do the second example on our page here. So I'm going to go a little bit more quickly with this one. First of all, we need to identify our line and our curve. So I've got a line and I've got a curve. How do I know? I know that this is my line because it has no power. I know this is my curve because it has a power on at least one of the letters. So the first step is to rewrite my line to isolate x. So I rewrite x minus y equal to minus 1 as x equals y minus 1. I put that in a box. I'll put a star next to it. Then the second step is to substitute in for x in my curve. So I've got y equals x squared plus 5x plus 1. And everywhere I had x, I now write y minus 1. Then I multiply out my brackets and I bring everything to one side. I'm going to have a quadratic equation. So I'm going to bring the y over. Y squared minus 2y plus 1 plus 5y minus 5 plus 1. And then I'm going to tidy that up. So y squared minus 1 minus 3 plus 2 plus 2y. 1 plus 1 is 2 equal to 0. And just double check that again. Aha, I forgot that 5 there. So 1 minus 5, that's minus 4, plus 1 is minus 3. So this should have been minus 3. Okay, so y squared, yes, minus 1 minus 3 plus 2, 1 minus 4 minus 3. And then I can factorize that as y plus 3, y minus 1 equal to 0. And I'm getting my two solutions, y minus 3 and y is equal to 1. So those are my two solutions for y. And now we can go on to, that was step 4 was solving it. And now we can go on to step 5, which is we use the star equation, the one that we have over here, to find the matching values for x. Okay, so let's look at what that looks like. When y is equal to minus 3, x is equal to y minus 1. So x is equal to minus 3 minus 1, and x is equal to minus 4. So we have the point minus 4 minus 3. That's one of my values. It's one of the points of intersection. The other one I'm going to use is when y is equal to 1, x is equal to y minus 1, so x is equal to 1 minus 1, x is equal to 0. So we also have the point 0, 1. And those are my answers. Those are the points of intersection of this line and this curve. Now I'm surprised that the first example was one that didn't work out. So when this happens, I'll just do a little note here. Note, when you can't solve the quadratic, that means that the line doesn't intersect the curve. Okay, so I just want you to try one of those for homework. We'll see how you get on with it. And we'll be doing a few more examples with these, but we'll take it slowly because I know it's a very new technique that we have. Do let me know, please, if you have any questions. Okay, thank you.